detail rows by that header, because we're going after the detail rows by the header, what we're going to need to be able to do is pick those detail rows up faster. If they're all on the same page, they're going to come up a lot faster than if we have some sort of primary key that we're going after, and then for the clustered, then using non-clustered to bring out the 5, 10, 12 detail rows. Clusters are great for queries with order by because they can help you avoid the sort. Non-clustered indexes are a bit slower, take up much more disk space, but are frequently the best alternative to a table scan. Non-clusters may cover the query for maximal retrieval speed. Now this gets interesting. I'm going to come back up to that non-clustered index. As we're looking at this, the leaf page of the non-clustered index may look to you remarkably like the data page of the clustered index. Why? Because we have sorted data on it, and we have one entry per row. What does that do for us? That gives us the capability of saying, you know, we have the information in there that we need. Why don't we skip the step of going off to the data page? This is a relatively common type of thing to do. The server does this automatically. You don't have to tell it to. What we find is that if most of the information that we're looking for is already in that page, in that data page, bringing a couple of extra entries into that data page gives us a performance benefit. So how does the optimizer do its selection? Well, the optimizer is going to identify what indexes match the where clause. Note that if the index doesn't match the where clause, it's probably a waste of time. Why is it a waste of time? Well, if I say, give me all of the people whose last name starts with a G, if I don't have an index on last names starting with a G, really doesn't make a lot of sense to go out there and play too hard. So we're going to identify all the indexes, estimate the pages to be returned. Why do we estimate pages returned and rows returned? Well, this gives us a handle on whether we should go ahead and use that non-clustered index or not. It may also give us a handle on what direction we want to join to get into. Joins are a little bit off topic for today. This is the single table lookups. Indexes need to match search arguments. A search argument is generally of the format column operator constant, or something that can be shifted to column operator constant. Why is this relevant? Well, here we have something where we say we're date of birth between 3/3/1941 and 4/4/65. Well, we can change this syntactically to say date of birth greater than or equal to 3/3/1941 and date of birth less than or equal to 4/4/1965. That will get us that kind of an answer and will allow us to set a boundary. Why does the boundary count? Well, what the boundary does for us is give us the ability to restrict the rows that are coming back. And that really is what a where clause is doing. Using the index to do that is simply the most efficient approach. So, SARG matching continued. Select star from the author's table where the author first name equals Jim. So the question here becomes, what are useful indexes for this? Well, sorry, this should actually have an index listed up here, and it has a name listed up here. I guess we have a little typo in the presentation materials. Let's just talk about these one at a time, and we'll come back up to them. What type of index is going to match select from authors where first name equals Jim? Well, this is going to best match an index on first name. Next one has select star from authors where the first name is Jim and the last name equals Smith. Well, question here becomes, is this something which is going to make sense for a first name lookup, a last name lookup, or both? Well, one of the things that we find is that in general, the server just likes to have a single index for an and. So we would have an index on last name, first name, or first name, last name. Note that an index on first name and a separate index on last name is a strategy that the server might try if it thinks it's got a snowflake schema type of thing out there and it has those types of indexes to come out and play with. Will not generally, though, and it will not generally unless you've got that OLTP thing set. That's the OLTP tuning default recommendation. last name equals Smith or first name equal Jim. Now we actually need to make 2 passes through the data. We're not using last name or first name to narrow things down. We're saying bring everything back. Because we're doing a bring everything back with the Smith or the Jim, what we need to do is bring both lists back. So an index on Smith and an index on first name really is what we need and what we're looking for. That, by the way, works out just fine. So 1 index on each, we bring it back. Depending on the circumstances, what we may end up doing is choosing to either bring the data back as it pops up, which is possibility number 1. Option number 2 is to use a dynamic index, which you'll sometimes see in your plans, which basically means because we may have some overlap between Jim and Smith, what we're going to do is make 2 passes, bring back a list of row IDs, perform a union across the row IDs to get our uniqueness, and then come back. So things which may drive you to using a clustered index. Ranges of value is great. Primary keys, not so much. Columns in which the data is frequently sorted. And by the way, when I say primary keys, not so much, a lot of folks make the mistake of making their primary key a clustered index simply because, by definition, a primary key is the way you're most often going after the data. It's not really the way you're most often going after your data a lot of the time. Sequentially access columns, because those will be on the same pages. Join columns for the reasons we've discussed. And we mentioned static columns here because when the row changes, if in fact the key changes, it has to move. For the non-clustered, if we're going after a small percentage of data, and here it says less than 10%, the documentation says 20%, has for a very long time. The documentation is a bit off. The non-clustered indexes, in fact, the number is frequently closer to 2%. We'll do the math on that in a little bit. Non-clustered indexes will help sorts, joins, group bys, etc. And non-clustered indexes are great for the index covering. We talked about index covering briefly. The idea behind index covering is we treat the non-clustered index, the leaf page of the non-clustered index, as if it is the data page of a clustered index. We walk the leaf page of the index and stay away from the data page. This is the one time a non-clustered index will be faster than a clustered index because we typically pack the keys a lot more tightly in that data page than we do pack the rows on the base table. Clustered versus non-clustered indexes, and I'm just skipping the examples. Well, I won't skip them too much. We have a limited amount of time to get through the rest of the presentation. The idea here is, so I'm just checking to see how far we've gone. We have a lot of stuff to go through. Short answer here is as we're choosing indexes, we have to be aware of everything else that's going on in our system. We do want to have a clustered index generally, because a clustered index can help give you lots of separate insertion points and avoid the tail end of the page chain as a single point of contention. Points down here at the bottom. If I want to bring back all the books between $5 and $10, we may get a lot of books. If I bring back all the books between $500 and $600, I probably won't get very many. What we'll do is, where appropriate, let the optimizer know how much data it's going after, because then it may have to help make that decision as to whether it's going to use or not use that non-clustered index. So, clustered versus non-clustered indexes. Here's some really quick math. Let's say we've got 2 million books. We fit about 40 rows on a page, and we've got about 1 million rows in our range of between $5 and $10. If we're using the clustered index, I thought I had a picture, I guess I don't. If using the clustered index, we can zero in on that first row that we hit and find the first $5 row. That costs us 3 or 4 IOs to get there. Once we get past that point, we'll scan, table scan, until we get to that $10 book, and then we'll stop. Why? Because we know that there are no more $10 books past the tail end of that. 1 million rows, therefore, using the clustered index, we're going to scan half the pages. So it's about 25,000 rows, or 25,000 IOs. For the non-clustered, we have 1 million pages defined, 1 million pages to request, 1 million is a lot bigger than 25,000. Non-clustered, not so much interesting, especially when we see that the table scan only costs us 50,000. So 25,000 kind of expensive, 50,000 more expensive. Using that non-clustered index, bad idea.